Hello and welcome to our latest webinar. I'm Phil Kell, Head of Talent at hackajob, and today we've got a webinar in partnership with the BBC. We're just going to give it a few moments for the event to fill up. So thank you to everyone who's in the early bird list. Good to see you all getting in nice and quick. We've got some really interesting speakers today from the BBC. They're going to give you some good context of types of projects that they've got going on there. We've got people from all sorts of walks of life and all sorts of areas of the business, so there should be some really good content for everyone to engage with. Just a few kind of housekeeping rules to start off with. Please do not use the hands up feature. We won't unfortunately be able to stop and get through to people raising their hands during the presentation. However, we do very much encourage the Q&A feature to be used. We do have a Q&A session at the end of the presentations. So please, if you have any questions at all, as we're going through these presentations, please get your questions in. We'll try and answer as many of them as possible during the Q&A session at the end. We are following up with an email after the event. So if there are any questions that are unanswered, we can definitely follow up and try and get those answers out to you afterwards. Okay, great. You can see we're filling up nicely. So I think, yeah, we'll be good to get into the introduction, and then I'll hand over to the BBC. So just to kind of introduce hackajob and the webinar itself. So hackajob is a data-driven and engaging recruitment platform operating in the digital sector. We use key data points to find candidates' jobs uniquely based on their CV and skill sets, ensuring both candidates and companies can conduct a more relevant and targeted approach to recruitment. Beyond that, we offer support before and after interviews, as well as offering candidates the opportunity to show off their skills through coding challenges and project uploads. And today we're joined with the BBC. I'm sure a company that needs no introduction. However, the BBC is obviously the world's leading public service broadcaster. They're impartial and independent, and every day they create distinctive world-class programmes and content which inform, educate and entertain millions of people in the UK and around the world. Just before I hand over, just to reiterate again, for anyone who's joined a little bit late, please do not use the raise hands feature. Please use the Q&A feature. We will try to get through as many questions as possible at the end of the presentations, and we will be following up with an email afterwards, which will give you an opportunity to get in touch with the BBC, book in some one-to-one meetings, as well as get access to the webinar content and any questions that we were unable to answer during the webinar. But that's enough from me. Now into the interesting stuff. I'm going to hand over to Noreen Adams, who is the Director of Archive Technology and Services at the BBC, and she'll introduce you to the rest of the speakers today. Thank you.
Thanks, Phil, and thank you everyone for joining. This is our first virtual Build the BBC event, so bear with us whilst we see how this all goes ahead. So as Phil said, I'm Noreen Adams. I'm the Director of Archives, Technology and Services at the BBC. But I also I'm very fortunate in that I get to be responsible for all our technology and product teams who are based in Scotland as well. So with all these things, the purpose is to get you excited about what we do, share with you the roles and opportunities that we have coming up, and give you a sense of what our teams are up to. Because with the BBC, we're very fortunate. We are across the UK and across Scotland, from Stornoway to Selkirk. We have offices and bases, so we're entirely flexible about where people want to work. As Phil said, please, if you have questions, we'll try and get to them at the end, so just use the Q&A function. But I'm going to stop speaking because I want you to be able to hear from Graham Lindsay, who's going to talk about our core services area, Lynn Dent and Paul Burt, who are going to explain what they do to do with archives at the BBC, and David, who's going to be telling us about iPlayer and sounds. So without taking up any more time, I'm now going to hand over to David, who's going to tell us about what's going on in iPlayer and sounds.
Thanks, Noreen. Okay, I'll share my screen. How does that look? Can you see that? Brilliant. Okay, so my name is David Buckhurst. I'm Head of Engineering for iPlayer and Sounds. And yeah, I just wanted to kind of talk a little bit about, I suppose, this summer, which we've called the Summer of Sport, where we had about 8 weeks of really high-profile events, and kind of what that meant to our engineers and teams as they had to kind of deal with that high volume. So this is me. So I joined the BBC 9 years ago, November 2012, just after the London Olympics. So this is a picture of me arriving on my first day. But I really felt like I'd sort of missed out on something, because the sort of got there and everyone was talking about the Olympics. There was this massive buzz, like there was this sort of real sense of the whole company sort of pulling together to deliver this great experience for the UK. And I sort of missed out. So fortunately have had plenty of opportunities to kind of experience similar. But just to kind of talk a little bit about where I came from, I started as a software engineer working on the BBC's smart TV applications. So you can kind of see end of 2012, there was about 1.5 billion stream requests. So iPlayer was like, it was still like a fairly big deal, but you know, it still had quite a long way to go. So in the 9 years since, like, and particularly like the last couple of years, you can really see how kind of that growth has exploded. You know, particularly with lockdown and sort of the change of behaviours. A lot of that growth has been driven by you know, the smart TV applications. So yeah, to talk about the summer then. So yeah, it was a number of events. It kind of broke all the records we had with sort of this triple whammy of the Euros that have been delayed from the previous year, Olympics that were delayed again, Wimbledon at the same time, and to top all that, we were doing UHD trials. So it was fairly massive. We had about 7 million people watch the Euros final on iPlayer. 1.4 million watched the Wimbledon final on the same day. You know, Tokyo Olympics was massive. But like, we often talk about the kind of the scale of an impact of our engineering at the BBC, and you know, we have big audiences, we have really impactful products, but you know, what does that actually mean when you work in a team in the BBC? You know, I think someone great once said, with great power comes great responsibility, and this was 5 years ago. You know, there's nothing quite like your failures being on the front page of the Metro or indeed the Radio Times to motivate you into getting better. So, you know, how do teams prepare for sort of 8 weeks of something like a high profile event? Well, it really starts with acknowledging failure. So 5 years ago, yeah, we failed big. Final 2 minutes of an England game. I think it was yeah, one of England's few wins at the time, and basically we sort of absolutely bombed out, kicked everyone out of iPlayer, you know, and sort of took out the whole BBC systems for about 4 minutes, which was enough for everyone to miss the end of the game. So yeah, so we've you know, we've learned a lot about how you deal with kind of that large scale event, how you deal with failure. We have something we call our post-mortems process. Here's a little picture of the template we use, but it's one of the key tools we use for driving improvement. So whenever we have an incident, the team will run a post-mortem meeting where we kind of run through the timeline of events, talk about what happened, and it's really about trying to not only just, you know, fix the problem, but also kind of understand what happened, understand how we can get better at dealing with issues like that in the future, and also, like, how do we just make sure it never happens again. But the real key thing for teams is it's a real blame-free process. So it's about driving action without any blame at all, and that's like this big cultural kind of thing we've sort of embedded into the teams we have at the BBC. So yeah, so obviously there's months, if not years, of planning for a high-profile event. Distribution, manage our CDN capacity, you know, and that takes, you know, probably 12 months of planning. But for the teams that actually build the products themselves, you're talking a couple of quarters before we start to talk about, you know, what are the changes we want to make to improve the product? What are the you know, what do we need to understand about the kind of traffic we'll have, so that we can scale appropriately. So this is a picture of our counting service that we use for monitoring the kind of by the minute live streams so that we can understand, you know, what the impact is on our CDN capacity. Something like, you know, 4K streams are really kind of heavy in terms of bandwidth capacity. So, like if everyone was watching you know, the Euros games in 4K, that would probably exceed the capacity of UK internet. So we have to be quite careful about, you know, making sure we're sort of not overloading UK networks. So what we do is we run an operational call every week, every Monday morning. We get together and we talk about like operational needs for events that are coming up. So actually for the summer, we were doing that sort of 3 times a week. This picture is kind of our usage profile, which anyone who works on iPlayer would be very familiar with. But obviously that profile changes in big events. The spikes become spikier. And so we, you know, we'll spend a lot of time talking about like how we're going to scale and how we're going to provision additional compute for a big event. So not that long ago, that would have been a change freeze. We would have totally locked down our code bases. You know, only the most severe bug fixes would get released, whereas we actually moved into a model of sort of encouraging more releases. So you can see this graph actually captures our number of releases for iPlayer any given month, and you can see July, which was really the peak of the summer. You know, it exceeds the usual number of releases we'd make. So you know, and so we encourage, you know, small frequent releases to reduce risk, but also we're constantly running experiments. We're changing our telemetry to better understand what the users are doing, and changing our scaling rules probably on a daily basis. So it's, you know, it's actually more change that helps us provide that better experience rather than kind of freezing everything. So of course, you know, despite all the planning we do and all of the kind of work we go into to make sure we're in a great position, the worst, you know, disaster strikes. The worst often happens, as it did lunchtime just before the first Euros match. Something went catastrophic, absolutely kind of failed certificate renewal problem that took out iPlayer and half the BBC sites for. And we absolutely had no idea what had happened. So everyone was mobilized on a call. We slowly worked out the problem, and then teams, you know, kind of in a priority order, brought back all the systems we need so that we could provide that iPlayer experience for the kickoff at 8 o'clock. We also use things like we have an instant commander process, which is really helpful for just kind of coordinating. Yeah, instant commander is a way that we can kind of coordinate dealing with an incident. So a big incident, there might be 4 or 5 teams, they're all dealing with it. You know, there's a lot of change going on. So you kind of need an incident commander to kind of keep everyone working together and provide that voice of calm. So if you imagine there's loads of stakeholders, all want to know what's going on with the team. Incident commanders, kind of that voice of reason that keeps everything working. Okay, and yeah, and on call, probably worth talking about that as well with a big incident. So most of our teams provide some kind of out of hours support. So, and the way we manage this is it's an addition to your sort of standard BBC contract and something you opt into. But actually, most of our teams, you know, the engineers are on call. You know, we pay for, you know, on-call rates for both being on call and being called out. But the way it works is we operate a no change policy. So, you know, we never make a code change, but what we do is we manage our feature toggles. We call them dials, so that we can, you know, turn off parts of the service if we're having issues, or change the scaling, or turn off a particular capability for a certain set of devices. One of the things we'd normally do for big events is live monitoring. So get into the office for the first couple of days, monitor live traffic, but it's an amazing opportunity to learn about real audience behavior, but hasn't been something we've been able to do during the pandemic. So we've all been doing that at home. sort of had lists of what devices people have had. Usually we'd have access to our device storage so we support about 8,000 different TVs, so we often need them on hand to be able to investigate issues, and that's kind of been done, I guess, with people's own personal devices over the last 18 months. Anyway, just to conclude, really, our main weapon in sort of the arsenal to be able to constantly iterate and to deal with kind of issues is our ability to be able to iterate and learn. So as well as the instant postmortems, we do regular retros. I think this is a picture of the one where we actually made the decision to get rid of code freezes during events. So we do constantly change our approach to how we deal with live events. And yeah, and I guess the really big thing we learned that, like, after a year of like no big sporting events, was just how important these things are to our audiences. So they turn to us in their millions. You know, we really are in this unique position to provide an amazing experience for the UK population. I think these are some examples of what's coming up next year. So it does never end. You don't miss out. Thank you. Let me stop sharing. Great. We're going to do questions at the end, but in the meantime, I'll hand over to Graham.
Super. Thanks very much, David. Let me start my own. Okay, cool. So my name is Graham Lindsay. I'm an engineering manager for Core Services. Core Services is not one of the known brands. You know, these are the brands people think about when they think about the BBC, news, sport, Bite Size, the major websites that are known and loved around the UK. We are a platform that sits behind that. We're the platform that powers the biggest news website in the world, one of the biggest and most loved sports websites in the UK, BBC Bite Size, and the homepage, etc. What I wanted to talk to you today, you know, we don't have things that are quite so shiny to show as other products. So what I wanted to do is maybe take you on a journey, tell a story, and sort of draw some pictures that maybe explain what actually happens when a user loads a BBC web page. So here's a little browser. We put a URL in, going to go to the news homepage. We hit that go button, and as a user, a page loads. Lovely. But what actually happens between hitting that button and getting that page rendered? That's where we live. So to open up Core Services a little bit, there's three main layers that we look after, that we use and operate to render the web pages. They're called Belfrage, Presentation, and Fable, and I'll go through each of these in turn. When the initial request is made, it goes through some edge networking magic, and it will arrive at Belfrage for us. Belfrage is a system that we use for routing, resiliency, and high availability. So what that means is that all of those incoming requests coming from users around the UK and further afield are being dealt with by the Belfrage system in the first instance. So huge concurrency, latency, keeping latency down is incredibly important. And under relatively routine conditions, the system will deal with 3,000 to 6,000 requests per second, so 360,000 an hour. That's under normal conditions, but we do see abnormal conditions occasionally. So we'll see instantaneous spikes. Sometimes they're for good known reasons. So for example, a breaking news alert goes out to people's mobile phones. They get a notification on their phone, click that notification, and it takes them to a page on the BBC website. So we see these instantaneous spikes that happen for very, very short periods of time that are very, very intense, and we can spike up to 400,000 requests per second, and we've got to be able to deal with that. There are other reasons that we see spikes. So we have a lot of crawlers out there that do things, and there's, occasionally we see bad actors as well who are doing whatever it is they're trying to do to the BBC website. BBC News as a website is seen as a really critical system. I think one thing in the last, the 18 months or so of the pandemic, we have seen those periods of time when people have really, really leaned as a nation on BBC News website. We've seen that, just this week with Facebook and Insta going down, what the consequences are for major digital systems when they disappear off the grid. BBC News website is definitely one of those systems that people are going to notice if they disappear. So what Belfrage is able to do, it's our first line of defense. It's able to monitor for duress in the rest of the system and do what we call circuit breaking. So what that means is it starts to serve cached content back to the user. So the users are always seeing content. But for us, we have attention, especially for the likes of BBC News, where having fresh content is important as well. People expect updates to be relatively quick, or if you're going to go to the sports website to see what's happened, what the latest score is on a match, you don't expect it to be 5 minutes out. You don't expect to have to wait a long time. So we have to deal with that tension between caching and freshness of the content. From a tech point of view, we run on EC2 and Amazon AWS. We use an interesting language called Elixir, which is actually a framework that sits on top of a language called Erlang. So Erlang, if you're not familiar with it, was designed for telephony systems. So it's really, really well suited for modeling high concurrency, low latency applications. Okay, all being well, Belfrage is then able to pass the request on to the next layer in the system, which we call the presentation layer. The job of this is our React single page app. There is a lot of development work that goes on in this area because this is where all the content is generated. So there's many, many teams across many, many products who are all contributing into this layer. From our perspective as a platform team, there's two main aspects that we own within this. We own the core React framework. So this is a framework on top of a framework. This is responsible for the standardization of the composition of the web pages. So we're trying to bolt in the BBC paradigms, the paradigms of the web pages, so that other teams don't have to constantly recreate that. We also own the design system. So that's a standard set of UI components. And what that allows us to do is bolt in accessibility and usability really early in the journey. And accessibility is something that we're really proud of as a department, and we like to think that the BBC kind of leads the way in terms of web accessibility. And as I said, there's lots and lots of teams who are building onto this monorepo. So we've got over 100 engineers at the moment, and more are coming all the time as more content is migrated onto this platform. As a department, we manage the deployment and CI pipeline. So at the moment, we're managing about 6 to 10 deploys to the audience per day. So, about once an hour. We're trying to enable and facilitate continuous delivery for all those other teams. So we've got aspirations of getting that up by an order of magnitude. From a tech point of view, it runs on AWS Lambda. There's some good blog posts out there if you're interested in details of this. It's obviously React, and from a Lambda invocation point of view, we do about 25,000. Okay, so the presentation layer is responsible for kind of the core constructs, starting to build up the layout of the page. Obviously, then what it needs to do is get the content to populate into that. And that's where it makes a call down into the final layer, which we call Fable. The responsibility of Fable is actually to call out to a myriad of other services, which we refer to as platform services. These are the services that are at the end of the content workflows. So there's lots of journalists and various other content people building content inside the BBC across a myriad of different services. The job of Fable is to aggregate that, so to build connectors through to these various different systems and bring that data back, aggregate that back together, and then it's passed back up to the presentation layer, which will hydrate the page, generate the HTML, and pass that back. All those other teams out there who are all busy building content, so this might be news teams or sport teams or homepage teams or various other teams, they're able to build their own Lambdas, put that into the Fable ecosystem, and Fable will manage the running of those Lambdas for them. So it's almost like a plug and play setup we've got. There's also various caching techniques you can use at this layer as well. And obviously we again come into that tension between the freshness of the content versus our ability to cache it. From a tech point of view, it's a Lambda sandwich between two EC2 layers. It can handle about 300,000 requests per minute there and pass that back to the presentation layer. Okay, so everything being well, all of that data gets aggregated by Fable. It will be sent back to the presentation layer, which will hydrate, generate HTML, put that back through Belfrage, and there we go, web page for the user. So just looking at that in the round, for an entire platform, we're aiming for 4 nines availability, so 99.99% availability. We're hoping the users will see new content within approximately 90 seconds of the content finishing the authoring workflow. Now, you know, Facebook, Twitter, these other competitors, they've very much commoditized the idea of putting a piece of content and having it around the world almost instantaneously. So that's a piece of work for us to continually try and improve. There's obviously a lot more to it than what the BBC are actually doing versus tweeting something. But, you know, that's the kind of order of magnitude that we're trying to get into to compete with them. Overall, per month, we serve about 2 million requests a month, and at the moment, 130,000 of them are personalized. So, 130 million of them are personalized. Personalization is very much the future of digital products, and the BBC is no different. Why that's interesting for us is that personalization means unique. It means you can't cache it. So we have to build this platform to be able to scale up to the orders of magnitude of uncached content. And all in, the round trip time for this time to first byte is about 170 milliseconds at the moment. So that's the system that runs, that generates and builds the web pages for it. That's the thing we own and maintain. But there's a final element to the core services mission that we call developer productivity. So this is our developer tooling and support mission. So the aim of that is to accelerate other teams so they can build all the content and use content, support content, whatever it is they're building, to try and let them go faster. We do that by collaborating with them, by supporting them, by defining the patterns and paradigms, but also by creating tools, documentation, and defining the golden paths for the other developers to follow. As I mentioned before, we also look after the CI pipelines for the teams, and we're sitting at about 13,000 builds per month at the moment. That's us. We're Core Services. We own and operate a major platform. We use a wide range of technologies and AWS services, and we support and collaborate a huge range of teams, which makes things very interesting for us. And that's us. So I'll finish up, and I think I'm passing over to Lynn.
You are. Thank you. Right, let me just share my screen and hide some bits. Okay, there we go. Right, hello folks. Thanks for coming along today. Myself and Paul Burt are going to talk to you about the department we work in, which is called Archives, Technology and Services. Talk a little bit about the BBC's archive, but also how we use technology to open up the archive to our program makers and take receipt of content into our ecosystem so we can publish it out to iPlayer, so we can put it on the telly, etc. Oh, my buttons aren't working. There we go. So this is what we look like, just to make sure that we do exist. We took this on Tuesday when we were actually in the building, which we're very proud of. It's a beautiful building. So what do we do all day? What do Paul and I do when we turn up at work every day? In a nutshell, we do this. This is obviously a very high level explanation of it. But we're the team responsible for our program makers delivering content into the BBC prior to transmission. These are TV programs. We do some QC checking. We make sure they're okay. We make sure they're ready for transmission. And then they appear on your TV. They appear on your EPG with all the data that lets you record them. And that's all cloud hosted. Once a program is transmitted, it's then automatically archived into our high resolution archive system, which we'll talk about in a wee bit more in just a second. That all happens automatically based on transmission data that is sourced upstream. And we are very aware that as the BBC, we've built up numerous archive repositories across the years. So we also have built and look after a single shop window, which lets our program makers search across the archive content so that they can go and find the content, reuse it, repurpose it, get it back out in front of our audiences. Everything that we do absolutely has to be secure. We have to support all of these systems. Everything has to be observable. And we do this by working in multidisciplinary teams. So within our teams, we've got software engineers, product people, business analysts, testers, systems engineers, who all come to work every day and make sure that we can provide this brilliant service to our program makers and people delivering programs into us. The volumes and numbers that we're talking about is quite staggering and enormous and a joy to work with every day. Our high-res archive store is 20 petabytes. Now, given this is the BBC's archive, given some of this is pre-transmission content, it's invaluable and a lot of it is irreplaceable. So we have a 2+1 storage architecture, which means we have 20 petabytes in each of those physical stores. One of the exciting things we have coming up over the next few months, years, is moving from on-premises storage to cloud-based storage for our archive. And we'll be the first archive in the world to start doing this at such a scale, which is super exciting. We don't have the amount of users that somebody like Graham has in terms of millions of users, but we do have 10,000 active users. All of these people are program makers who've been commissioned to make content for the BBC. So we are very important to them. We're important so that they can deliver their content in, so that it can make it onto your TV, and so that they can go and research and source new content to make sure they can repurpose it up into the program that you'll see on your TV tonight. In terms of our ingest pipeline, so we have a very solid pipeline where we can ingest around about 400 TV programs into our archive system every day. That might be a program that was transmitted on the TV last night, or actually it might be some beautiful film from the 1940s that's been digitized by some of our colleagues in London. It's a huge amount of content moving about, and what Paul will talk about is for our end users, these numbers are huge. For our end users, it needs to feel easy and a seamless interaction. So an HD program, for example, is about 25 gigabytes. If somebody is transferring an entire program from our archive system out to an Avid for an edit, etc., they shouldn't need to know it's that big. They shouldn't have to worry about it. It should be easy and seamless. In terms of user volumetrics as well, we see roughly about 18,000 user-initiated high-resolution exports out of our archive system every month. That's around about 50 terabytes. So these are all instances where somebody who used one of our systems to go and do some research, find some content, an archive they think is brilliant, and they want to reuse it in a program. So we do see quite a lot of reuse out of our systems. And we allow our end users to search across roughly 75% of the BBC's archive. We're almost 100 years old. We have multiple archive systems, as I said, which have different data models. They've got different file formats and codecs. So being able to surface that amount of content through one user interface has been quite a challenge, and we're extremely proud of it. So a couple of very random looking pictures to give a bit of a backstory and a bit of context around about what the BBC's archive is all about. So the photo on the left-hand side with all those angelic looking school children, that's my entire primary school. I am there somewhere, I'm not telling you where. It's not half the school, it's not one class, that's the entire school. I grew up in Aberdeenshire, in the middle of nowhere. There wasn't much going on. There was definitely more sheep than people. And the screenshot down at the bottom right-hand corner and the chap with the big arrow above his head is my granddad. And he exists in the BBC's archive. There's some film footage of him from 1964. He worked for Aberdeenshire Council, clearing the roads, mending roads. And what he's doing here is clearing some snow, using a snowplow. Now, I've never met my granddad. He died before I was born. Working for the council is very important, but he was just somebody going about their job, just somebody clearing the road, making sure people could get about on that very snowy day in the 1960s. Why on earth am I telling you this? This is an embarrassing photo. Why am I doing this? I'm doing it because what I really want to talk about is the BBC's archive is a memory of the entire UK for almost 100 years. We're not quite 100 years, we're almost there. So we are a working, living library and archive. Our program makers make use of our archive content every day. However, if any of you were to come and work for the BBC and get access to these sort of systems, go and look up your school, the place you grew up, where your mum and dad worked, there will absolutely be something there for you. There's a huge emotional resonance with those day-to-day pieces of archive that we have that are not just the big brands. It's not just about Strictly, Blue Peter, Newsround, Danger Mouse. It's about those brilliant little snippets we have of everyday life from the UK as well. As you can imagine, the BBC's archive is very much a reflection of the times. Just a few examples here. The chap in the top left was being interviewed as he stepped off Windrush. We don't have to dive very deep into the archive to find content that we wouldn't transmit in its rawest form now. We certainly won't be putting any Miss Worlds up on iPlayer. And as I said, it's a reflection of the social mores of the time. So the two examples on the right-hand side were Vox Pops, where a journalist would go out into the streets, interview somebody about something fairly innocuous, and they would give their opinion. So the chap with the groovy glasses was asked if he would rather marry a pretty girl or a brainy girl, which is interesting in itself. However, he's also somebody's dad, granddad, uncle, teacher, we don't know. But again, it's about that link back to the UK and being a mirror and representation of the last 100 years of our history. I know I'm talking to lots of people who care about technology. So what is also brilliant to go and look at in our archive is how technology has changed. Some of you might remember a series called Tomorrow's World. Technology doesn't age terribly well. So if we go back and look at these, there's lots of chat about dot matrix printers and mainframes and something called the internet, which, you know, it might work, it might take off. So how do we do all of this? How do we open up the archive to our program makers? How do we make sure that people can deliver content into the BBC? Paul.
It's my bit. Hi, nerds. Good afternoon to you. My name is Paul Burtz. I'm the engineering manager for the archives. So before I get into how we do it, I should say it's a very cool set of toys to play with. I hope, as Lynn has persuaded you there, you've got literally 100 years of British media to have a look at and play with, which is, I think, an extremely exciting problem space to work in. And it was the thing that attracted me to working at the BBC. So how we do this? Well, Lynn's already pointed out that we have what we call a shop window on the archives, which is, in my very crude analogy here, the bit above the waterline. So we present out to the world in our case being program makers, hopefully rather lovely tip of the iceberg, which is a React.js web application. And that is, in essence, a one-stop shop to make it easy, frictionless, and just a generally lovely experience to find what you're looking for in the archives. Whilst we do all the hard work of actually connecting all that together below the waterline, which is where it starts to get difficult and ugly and multi-vector. So my engineering teams work in a broad range of technologies, but one thing that unites us all together is an increased usage of Node.js or JavaScript as an isomorphic language solution to crossing the front-end, back-end divide. So that's something we're trying to do across BBC teams, and you've probably heard from Graham there and from David that Node.js features quite highly in everything we do. So this is also a great opportunity for internal mobility in terms of your own career at the BBC. You might decide one team excites you, but you can still go and use the skills you've developed in another to transfer your skills to the next team. So that's something we care about at the BBC. We do have quite a complex estate in archive services, but in the general trend now is to move into Node.js and into Amazon Web Services. So I think Lynn's already mentioned the fact that we don't have millions and millions and millions of end users in the same way that, for example, David and Graham do. However, we have our own set of problems. So we have a very important set of users, often doing production critical workflows and trying to get things back into broadcast. So for example, doing a summer of Glastonbury footage when we're in a pandemic, we want to make it as easy as possible for people to find what they're looking for, not have to worry about what the arcane old BBC system was that it came from originally. Just find me some Glastonbury footage and give me the ability to download that in broadcast quality so I can then ship it into my new program. So the bit below the waterline is essentially loads and loads of historical systems from the BBC, but also the modern iPlayer pipeline. So we're taking broadcast our browse quality media, rather web quality media, in from the same pipeline as iPlayer. and also broadcast quality from various other systems, which we don't want our end users to have institutional knowledge of. They shouldn't have to know, okay, it was broadcast in Scotland, so I need to go to that system and I need to use this login for that. So our goal over the last several years has been to completely eliminate all that institutional knowledge so that a user can just come to the system, log in with their BBC ID and find whatever they're looking for and not have to worry about the rest of it. And the other thing we are doing, of course, is adding a whole load of metadata to those assets. So, you know, who appears in it, who wrote it, does it have any restrictions? Can I actually rebroadcast this legally? That kind of stuff. So I like to think of archive search really as an iPlayer with access to 100 years of content. But obviously we can't give the keys to that particular garden to everyone, but hopefully it's a really lovely tool for our end users to use inside the BBC and in independent program making organizations. So here, a very dry list. I know this is really boring, but this is a list roughly of technologies that we use in archive search. As you can see, it's quite diverse. So Node.js, React.js, those are not going to be surprises to anyone these days. JavaScript has taken over the world and you can have opinions about that, but it's probably immutable. It's taken over the world anyway. Cypress.js is something we use for end-to-end testing. So as you can see, there's a lot of JavaScript. If you know JavaScript, you can hit the ground running at the BBC. But also, as I've probably hinted in my previous slide, we have a lot of kind of arcane old systems that are running in premise in London and all over the UK in offices from a time before the cloud, before Amazon Web Services and Microsoft Azure, etc. So we do have some Linux systems, some bare metal systems. And so therefore, people that have an interest in that kind of thing are also likely to have a good time in archives. There is not, the goal is to reduce that amount of on-premise stuff, but it's going to be a big part of our future still, because archival preservation is a very expensive thing, as you can imagine, and that could giving all your content in petabytes and terabytes to one large American multinational maybe isn't the best thing to do. Although but that's definitely part of our solution, is to provide access to content quickly in the cloud, but to also have a preservation layer inside the organization. So if you know about Linux, Unix, systems engineering, Python's useful to us, Docker, Ansible, if any of those things look exciting to you, then definitely come and have a chat with me. So can we go back just quickly, Lynn? Elasticsearch is hopefully maybe known to some of you. So archive search is essentially a search engine that leads you through to lots of bespoke BBC content. But we need obviously a search layer. So at the BBC, we tend to we stand on the shoulders of giants. So, you know, we don't want to implement our own cloud, our own search engine when someone else has done it already. So we use Elasticsearch to do our search engine. And below that are a handful of the Amazon Web Service components that we use. So Lambda, again, I think Graham mentioned the Lambda sandwich. We're very similar in this regard. DynamoDB, S3, notifying and observability monitoring, we do via SQS and SNS and log into CloudWatch. So those are standard, I guess, becoming canonical Amazon Web Services design patterns. Okay, so sorry for this naff slide, but I thought it was fun. So far in our evolution, we've been focused on, as I said, making it easier to get into the archives. And it's really been focused around people who kind of know what they're looking for already. So if you've got a week to make a program about, let's say, Boris Johnson springs off the top of my head, I'm sorry. So you've got to find certain certain assets in the BBC archives about that. You kind of know what you're looking for, probably already. You might even know when it was broadcast, what channel it was on. But the next step in our evolution is probably to take all these petabytes of data that we've got and start to make more intelligent decisions based on them, things that we may not have thought of, patterns that may emerge from the data. So one of our first steps along this journey has been using transcripts. So we use a machine learning service produced by our colleagues in BBC R&D called speech to text. So all of our assets are run through that. So they may already have subtitles, but they may not have a detailed audio description of what happens inside the asset, and the metadata might just say, you know, natural history program X that went out on a certain date. There was nothing more. So let's say you're looking for this unusual bird, which is called a quetzal. I'm reliably informed the pronunciation is. Very unusual word, very specific. It's not mentioned in the metadata for this particular program. We now enable you to find it because we've done a transcript of the audio and made that available in the Elasticsearch index. So you can now type in the word quetzal, and it will not just take you to the asset, it will take you to the exact frame in the asset where that word is first mentioned, and directly linking you, as you can see, from the asset straight to the bird in question. So all sorts of things have actually emerged from the BBC archives because of that early stage in machine learning. And that's going to feature more and more in our future. So if you're interested in data munging and you know, schema on read, schema on write, I'm dropping some nerd lingo here. If those kind of things are interesting to you, then you will probably find our train set quite fun to play with as well.
And it's worth kind of, you know, circling back to why do we do this? So we have an obligation via the BBC's charter, excuse me, to archive our broadcast content. But as you can imagine, over the last 18 months during COVID, there were a bunch of TV productions that just had to shut down. We were making less programs. So because we have spent such a long time caring for, curating our archive, it meant that we could publish lots of brilliant content up to iPlayer. It meant in the last 2 years, when there's been no actual Glastonbury Festival, we've managed to bring a really brilliant editorial proposition to iPlayer Red Button round about Glastonbury. And in amongst those 2 years, it was actually Glastonbury's 50th birthday. So again, deep archive of just absolutely brilliant content, that a lot of which have never been seen before. Which makes, you know, if we had to convince you anymore how compelling and brilliant this was, all the Glastonbury, it's great.
Thank you very much to all of our speakers. I think you did an amazing job there. Loads of really, really good content for everyone out there to engage with. We haven't actually got too long left for Q&A, but we'll see what we can get through in this 5-minute period. As mentioned at the start, though, we will be following up with an email. So if you do have any unanswered questions, we can definitely get back to you in that way, and also give you some options to get in touch with the BBC if you've enjoyed what you've heard today, which I'm sure you all have. Great. So I think first question that we're going to look at is for yourself, Graham. So someone's asked if you could please give some examples of what you use AWS Lambda for in Fable and what the process of migrating over was like.
Yeah, so the Lambda modules that are used in Fable, Fable from our perspective is just a thing that runs code that is given to us. So it's a good example of how we actually do the migration. So the sort of things that tend to run inside those Lambdas is somebody needs to access a new system that either somebody has already used it, in which case we can reuse it. If the module is not there that is interfaced with that system before, they can build that themselves. And how do we do the migration? I think that's like a key example of one of the mindsets that we need to have as a platform team. Building a platform can fundamentally disempower other teams. So our job is to try and elevate the platform up so that it enables other teams to operate in a self-service mode. So that's a very common theme and for some of the kind of developer productivity work that we talked about there.
Fantastic. Thank you very much, Graham. And David, if we could come to you next, just to explore a little bit more about how collaborative the work is between the various different teams at the BBC.
Yeah, absolutely. I don't think I've ever worked anywhere that, with more of an emphasis on collaboration. So iPlayer itself is about 30 teams, and also Sounds works very closely as well. Like we share so much that it would be impossible to do our job without day-to-day collaboration. We have teams that kind of flex and work together continually. We also I guess we also do things to make sure that collaboration happens, even when there is a tendency for kind of silos develop around product groups and things like that. So we have guilds, we have hack weeks and things like that, where we really kind of overemphasize the kind of need to do things cross team and bring people together like that.
Fantastic, thank you very much. Lynn, if I could come to you next. We've had a few different questions all about kind of joining the BBC and what's it like to, what they kind of expect either from the interview or just in terms of initially joining the BBC. So perhaps you could give some insight into what it is like, when you've got a new team member and what they could expect during their kind of initial steps with the BBC.
So in terms of interviews, we're very aware of diversity and inclusion. So we try to make sure that every interview panel we run is a diverse panel. We don't want you to be faced with a row of chaps with beards. We like chaps with beards, but not just chaps with beards. When you join us, obviously, we want this to be as smooth a process as possible. Somebody's joining my team at the moment, so we're having a bit of back and forth with questions, making sure that she's comfortable coming to join us. Where she going to be? Would she like a Mac or would she like just a normal laptop? That kind of thing. And making sure that we have realistic expectations about what people will do in their first 90 days. You'll get to know the domain, you'll get to know your team, you'll start to get your head around some bits and pieces, but just being clear, welcoming. And from my point of view, whenever we have new engineers join as well, absolutely in the first week, sit down and talk them through a big picture of what is the purpose of what we're trying to do. I would hate that anybody ever joins us and feels like they're just coding into the ether. That's dreadful. So what are we trying to achieve? What's our business purpose? What's our North Star? And just really talk them through that and make sure they feel comfortable and know where they can come and ask questions, get them a buddy in the before times, go for lunch, that kind of thing.
Fantastic, thank you very much, Lynn. And that is actually us at time now. Obviously, we're at the hour mark. So, look, thank you very much to everyone that has joined. We had lots of other questions to go through there. It's great to see how engaged everyone was and how much information everyone did want to know. As I've mentioned a few times, we will be following up, so don't worry. We will be able to get those answers over to you and obviously give you an opportunity to get in touch with the BBC. And Noreen, I think you wanted to jump in at the end just to talk about some one-to-one meetings that the attendees could get involved with.
Yeah, absolutely. Listen, thank you to everyone who's attended and listened. I should have known that an hour was never long enough because any of these people, as you can tell, they have real passion for what they do and can never keep to time. So because of that, what Phil's going to do for us and the great team at hackajob is they're going to help us coordinate if any of you want to have follow-up one-to-ones with anyone on the panel or also some of our other colleagues or other teams. We can make that happen just so that you get more of a chance to ask your questions and have a bit more of just an informal chat with us, because we're here, we really are passionate about what we do. We'd love you to come and join us. Next year's our 100th birthday and there's going to be loads happening. So thank you, hackajob. Thank you everyone who joined the panel, and thank you panelists who, as always, passionate, enthusiastic and talked for longer than they were meant to. But thank you all so much. Thank you.
Yeah, thank you to everyone that's joining, and please do keep an eye on your emails. You'll have an email from, I believe, events at hackajob with all of the information in it, in terms of how to get in touch, how to set those conversations, and also some great information to follow up on today's webinar. So yeah, I'd just like to second Noreen's thanks there. Thank you to all our panelists and everyone for joining, and have a lovely day. Thank you. Bye-bye.
Thank you, Phil.
Okay, thanks.